Okay, everyone, this video is just to check the last two systems of inequalities here. If you tried them on your own, you want to check your work, or if you're a little confused, or you just want to work on them along with me. All right, let's try number 3 and number 4. Number 3 first. So they're both linear, so that shouldn't be too bad. But let's go ahead and set them like I usually do. I do x plus y equals 3, and I'll graph that. And then over here I have x plus y is equal to -1. All right, let's find out what the solution is going to be. We're going to have to graph it one at a time and shade one at a time and get a final solution. All right, let's see if I can graph this down here in number 3. It's easier if these are both in slope-intercept form. So I'll say y is equal to -x plus 3. That's a slope of -1 and a y-intercept of +3. +3 slope-intercept. Now I have down 1 and to the right 1, down 1 to the right 1, and so on and so forth. Let me double check. On my inequality, this one is not equal to, so this will definitely be a dashed line. So here I can graph this line, but make it dashed or dotted. And now I can see, I can plug in 0, 0 to see am I going to shade the top right or the bottom left. So let me go back to the original equation up here. And let's see, if I plug in 0, 0, 0 plus 0, is that greater than 3? That simplifies to, is 0 on the left, is that greater than 3? If you think about it, 0 is definitely not greater than 3, so I'm not going to shade the bottom left that has 0, 0 in it. So I'm only going to shade the top right. Looks like this. All right, equation number 1 is done. And let's try equation number 2. All right, x plus y is equal to -1. Again, might be a little bit easier in slope-intercept form. That's the same thing as y equals -x minus 1. Slope of -1, y-intercept of -1. That's down here. And slope would be down 1 and to the right 1, down right to the right 1, and so on and so forth. Let's see, now is dashed or solid? I look at the inequality. He's also just less than, not equal to. So again, another dashed line. And that is equation number 2. All right, so now that's actually kind of a neat looking picture. Those one looks like those lines are parallel. Could we figure that just by looking at this, guys? Do you know if they have the same in common? Yeah, the same slope. Since they have the same m value or slope, they are parallel lines. Well, let's keep going and see what happens. Now I'm going to figure out, am I going to shade the bottom left of that or the top right? So I'll plug in 0, 0 here. Is 0 for x and 0 for y. Is 0 plus 0 less than -1? Meaning, is 0 on the left less than -1? If I think about that, is 0 less than -1? No, 0 is actually greater than -1. So I'm not going to shade the part that is 0, 0. So I'm going to shade the bottom left. All right, so both equations are done, both shadings are done, but now you know what we're supposed to do. Where do they both intersect? Where do they both overlap? Well, they're not. There's no spot where both shadings are overlapping. So the final solution, where they're both shaded, none. This one actually has no solution. That's interesting, that you can actually get a no solution with shading, because you can see these lines are parallel. They'll go on forever, and the shadings will never, ever touch each other. So there's no final shaded solution. That's number 3. Let's try number 4. And I'll copy number 4 onto the right side. Next page. This was x plus y is less than 3, and x plus 2y is greater than 3. Okay, I usually change them into equal sign. But again, that's a step that you don't have to do, folks, if you don't like doing that. Some people just get a little scared when they see the less than or greater than. They're not sure what that means. So I'll graph that. But again, it's probably better if I have that in slope-intercept form. So how about y equals -x plus 3. Over here, this will be y equals -1/2 x plus 3 over 2. Make that negative so I can see for sure. All right, here we go. Let's graph equation number 1. Let me get my XY grid over here. All right, let's do equation number 1, folks. That's y equals negative x plus 3. That's got a y-intercept of 3 and a slope of negative 1. So that'd be down 1 to the right 1, and so on and so forth. Let me check my original inequality. It's not equal to, so I'm going to call him dashed or dotted. All right, there's equation number 1, friends. Now I'm going to shade you the bottom left for top right. Let's plug in 0, 0 and see how we do. Back into the original equation. Is 0 plus 0 less than 3? Meaning, off here to the left, is 0 on the left less than 3? If you think about it, yes, it is. 0 is less than 3, so I'll shade the part that has 0, 0, which will be the bottom left. All this part right here. Have you tried using colored pencils yet, folks? It's a lot of fun. All right, let's do equation number 2. Equation number 2 has a y-intercept of 3 over 2, which is like 1.5, so he's right about here. He's got a slope of negative 1 over 2. That would be down 1 and to the right 2. So that would probably be another point over here, perhaps. If I go one more point just to be safe, I'd probably get another point maybe about over here. All right. Now, dashed or solid? Let's go back and check. It is dashed. So here we go. And that is equation number 2. All right, it doesn't go through 0, 0. That's good. Let's check it. We're going to shade below left or up to right of it. Let's plug in 0, 0 back here. Is 0 plus 2 times 0 greater than 3? Meaning 0 plus, well, 2 times 0 is also 0. So is 0 on the left greater than 3? Think about it for a sec. No, 0 is not bigger than 3, so we're not going to shade the part that has 0, 0 in it. That's going to be then the top right here. All right, final solution should be where they both overlap. And if you can see where there's both green and the yellow-orange, it's right here. I've got dashed, dashed, and in fact, it's probably going to go on forever up to the left. Since the green and the yellow will go on forever, the red will go on there too, go forever. So it's not bounded, it's not enclosed, it will go on forever. But that's kind of a neat looking solution too. And that's the answer for number 4. How did you do? Are we doing okay? If you did, great job. Congratulations.